So recently there's been a couple of minor problems going on in the big blue empty ocean. It turns out that we as humans are making it more acidic. Now, let me quickly explain how this happens. When we use fuels or burn stuff or kind of really anything including breathing, we release carbon dioxide gas into the air. So because it's in the air, it kind of goes all over the place, including our land and our water sources. And as our water meets the carbon dioxide, they actually mix together to form a thing called carbonic acid. And then this acid can essentially just break down into hydrogen ions, and then you have bicarbonate over here, which these two can actually go together and bump again to turn back into carbonic acid. You get what I'm saying here? Yeah, me neither. But the takeaway of this is that our ocean is going down on the pH scale, which is not very good. So what does this mean for our crustaceans? Well, first, what is a crustacean? Let's start with what isn't a crustacean. That is not a crustacean. This is rehabilitation, okay? We're looking for crustacean. This is not it either. This is actually resignation. That actually is kind of close, but that's identification. These are what I'm going to be talking about today. Crustaceans. And specifically, I'm talking about decapods. Now, what is a decapod? Well, a decapod is a crustacean that has 10 legs. So not this or this. Those are not decapods. Why is it called a decapod? Because deca meaning 10, and pod meaning legs. So 10 legs. Specifically in this, we're going to be talking about crabs and lobsters. All crustaceans have what's called an exoskeleton, hard outer shell that protects the vital organs of the body. This hard outer shell is made of chitin, which is a sugar molecule, protein, and minerals such as magnesium, and amorphous calcium carbonate. So it's pretty strong, but when exposed to the ever-dropping pH of the ocean, it gets weaker. For instance, there was a study done on the microhardness of these exoskeletons. Microhardness is essentially just the strength, hardness, and thickness of the exoskeleton. Microhardness ended up dropping a concerning amount, especially in the claws. See these little white bumps right here? I don't know what they're called, but they essentially just eroded away, and the claw microhardness diminished by 40%. Crustaceans have what we call carapaces. It's just where all their vital organs are. And these did not actually seem to be affected too much by the pH until they looked at what was going on inside of them. The pH changed the elemental structure of the carapaces. So what it did is it took the calcium and made it into magnesium. That's not what you want. What does that mean? It means there's less structural integrity for the exoskeleton. For the most part, you assume that acid, would dissolve things from the outside in. And as the claws show, that's true. But when we looked at the carapaces, it dissolved it from the inside out. Yeah, that's scary. Not for us, it's scary for the animals. So what's the equivalent of this? Well, imagine for a second that your bones, imagine for a second you were dipped into acid and then your bones started to erode away before anything else. Yeah, you can't do anything about it. It's not a very fun time. Now that we know what's happening to the decapods, what will happen if they die because of their weak exoskeletons? Well, for starters, we'd suffer. Many coastline economies would take an incredibly huge hit because less seafood means less money. And less seafood also means less animals where they live. Less animals in the areas of reefs. Coral reefs means less tourism. Less tourism, even less money. So all this just drops. And they're crashing. Their economies are crashing. Overall, the ocean acidification's it's a little bit of a problem. And now, how can we prevent or at least delay this? With this, I actually have no idea. I'm only here to tell you problems, so I don't know, do the research on your own.